What's the central paradox of AI governance? Our job is to prevent harm from AI, but without the potential for that very harm, our profession wouldn't exist. It's like in medicine, doctors are needed not because everyone is healthy, but because illness is a reality. Our field was born from the same understanding, that a powerful technology holds both immense potential and significant risks. And our ultimate goal isn't just to react to harm, but to diagnose and prevent it from the start. To build AI that we can trust, AI that is safe for people and beneficial for business. In our last lesson, we talked about the harm AI can cause to individuals. Today, we're shifting our focus to the ones who create and implement this AI. The ones who give us this job. We're talking about organizations. Because that's where the risks take on a financial and reputational scale. We will systematically analyze this threat, classifying it into three key areas: operational, reputational, and security, based on the authoritative NIST AI risk management framework. So let's begin. As we work on harm classification in this course, we rely on the internationally recognized taxonomy of the NIST AI risk management framework. It is a highly authoritative and widely used source. Many organizations adopt it as their primary framework for AI risk management. That said, there are other classification approaches based on different standards. We will work with the main ones and study them later in the course. It is important to remember, however, that regardless of the harm classification approach embedded in a given framework, the threat identification stage, identifying potential harms, is the critical first step for subsequent steps, assessing severity and likelihood, designing mitigation measures, and other actions prescribed by such a framework. We evaluate a system for the harms it can cause and take all feasible actions to prevent those harms from occurring. And if they do occur, we aim to make their impact and scale as limited as possible. In the context of AI risk management, organizational harm is the set of realized threats that exert a measurable or intangible negative impact on a company's assets and objectives. This harm may be a direct or indirect result of the operation, failure, or unintended behavior of AI systems. It is classified into the following key areas: operational harm, security harm, and reputational harm. Let's look closely at each category. By operational harm we mean the negative impact of AI on the day-to-day activities of a company. Within our classification, we split operational harm into two broad, interconnected categories. The first is harm to business processes themselves. This includes risks that disrupt internal workflows, logistics, planning, and decision-making. The second category is harm to product and service quality. These are cases where operational failures lead to a final product or service delivered to the customer that is defective, substandard, or misaligned with expectations. On the next two slides we will examine each of these categories in detail and review concrete examples that show how deeply AI can affect a business's operational stability. Harm to business processes is the stoppage or failure of an organization's key operations due to AI errors or freezes, leading to direct financial and reputational losses. We include system outages, full or partial stoppage of critical business processes due to technical faults in AI systems. For example, at a large warehouse, the sorting algorithm froze during peak outbound traffic. All logistics halted and the company lost substantial revenue over just a few hours of downtime. Algorithmic dependency, the loss of organizational know-how and manual procedures such that employees cannot perform basic functions without AI. For instance, after a year of success with a demand forecasting system at a large company, most planners were laid off, and those remaining forgot manual procurement planning techniques and were helpless when the model failed. Harm from inaccurate forecasts, financial and logistical losses stemming from AI model errors in predicting demand or load. For example, the algorithm projected explosive demand for a new device. Production made 100,000 units, but the model was wrong and the goods sat in the warehouse for months, tying up millions in working capital. Harm to product and service quality is the release of defective items or the delivery of incorrect, flattened, overstandardized services due to AI errors and limitations. Let's look at three types of such harm. Harm from automated defects. This is defective products reaching the market because of errors in AI-driven quality control. Consider an auto plant where AI-based computer vision systems conduct parts inspection. Due to a calibration error or insufficient training on rare defect types, the system begins to treat microcracks in metal components as acceptable. As a result, thousands of defective parts pass inspection and are installed in finished vehicles. When the problem is discovered, it leads not merely to a subpar product, but to a large-scale recall, massive financial losses, and, worse, a safety risk to people. Harm from reduced personalization. This is the loss of individualized treatment for customers when AI solutions provide the same recommendations to everyone, while the client cannot inject their particular circumstances into the interaction with AI. For example, many companies deploy AI to improve service but sometimes get the opposite effect. Imagine a banking chatbot politely offering all clients a set of deposit products carefully designed for specific segments. However, some clients want more individualized terms that reflect their unique situation, but find no such option in the interface, and the most solvent customers leave for competitors offering bespoke solutions. Harm from regulatory noncompliance. Fines, prohibitions, and loss of trust due to failure to meet industry standards and requirements. Consider a medical clinic using AI for preliminary diagnoses. The system may be highly accurate, but if it does not maintain detailed decision logs and cannot explain which data underpinned a given conclusion, that is a serious violation of medical standards. In an audit, the regulator may not only fine the clinic but also threaten to revoke its license. We have examined how AI can disrupt an organization's internal processes. Now we will move to harms that strike the most valuable and protected assets of any company, its data and its money. This is a category where consequences can be not merely unpleasant but catastrophic. Unlike operational failures, which often arise from unintentional errors, security harm is frequently linked to malicious actions. We will split this broad topic into two key areas. The first is information security harm, what we usually call cybersecurity. This includes all threats related to data compromise, system breaches, and manipulations targeting the AI models themselves. The second area is direct harm to financial interests, situations where AI's actions or attacks against AI lead to direct monetary losses, from industrial-scale fraud to uncontrolled trading operations. The first AI-specific threat is adversarial harm. This is AI's vulnerability to tiny, deliberate changes in its input data that trick it into making the wrong decision. In 2018, researchers at the University of Michigan and UC Berkeley conducted an attack where small stickers were placed on a stop sign, altering its appearance for a neural network but not for humans. A small sticker caused the autopilot to recognize the sign as a 45 miles per hour speed limit sign. The consequences speak for themselves. The system was not broken or hacked in the conventional sense, it was deceived. Such attacks can be used to evade facial recognition, spam filters, or malware detection systems. Harm from data leakage via AI. This is the compromise of confidential information due to inadequate protection or configuration of AI systems. Researchers at Google DeepMind in early 2025 demonstrated that a large language model trained on confidential documents can surface restricted information in response to specifically crafted prompts, even if such queries did not appear in the training set previously. Harm from data poisoning. This is manipulation of training sets, causing AI to learn and reproduce false or harmful information. For example, in April 2025 a real attack chain of this kind was described. An attacker gained access to a cloud storage bucket. The breach occurred on a contractor's side, so the developer's security team could not respond. The adversary then injected malicious data into a training dataset stored in the cloud. Such attacks are difficult to detect without specialized monitoring. The malicious samples are small in volume and are masked among normal data. Now let's move to situations where AI's operation translates directly into financial losses. These risks are particularly dangerous due to the speed and scale at which they can unfold. Algorithmic harm. The use of AI bots to create fake transactions or to bypass fraud prevention systems. AI is used as a powerful tool to commit crimes. For instance, a network of thousands of AI bots can mimic real user behavior to click-drain advertising budgets. AI gives fraudsters unprecedented scale. Harm from uncontrolled trading decisions. Losses caused by an algorithm autonomously opening or closing large positions with no ability to intervene. History includes real cases of instantaneous crashes triggered by algorithms, where a single error or deliberate action sets off a chain reaction among thousands of bots in the market. One of the earliest and most famous is the 2010 episode when an algorithmic chain reaction drove major U.S. stock indices down by 10 percentage points for just a few minutes. Since then, such events have recurred, inflicting billions in damage. Harm to insurability. The inability to properly assess and insure risks associated with AI systems due to uncertainty around liability. For example, there is an accident involving an autonomous truck. Who is at fault? The owner? The software developer? The sensor manufacturer that failed? Because of this uncertainty, insurers cannot properly price the risk. This leads to two negative outcomes: either insurance for AI systems becomes prohibitively expensive, or insurers refuse to cover such risks altogether. We have discussed how AI can harm operations, data, and finances. Now we turn to the most intangible, but perhaps the most destructive type of harm: reputational harm. This can be split into three categories. Harm from scandals. Public AI incidents amplified by the media that undermine brand trust. Imagine it becomes known that a large company's hiring algorithm systematically rejected women's resumes. The story instantly hits global headlines. The company is accused of sexism. Social media erupts with calls for a boycott. This deals a crushing blow to the employer brand and the company's image overall. Ethical harm. The use of AI in ways that contravene societal norms, prompting public condemnation. For example, a social network uses sophisticated AI algorithms to show users content that elicits strong emotional reactions and keeps them on the platform longer. When an investigation reveals that the company consciously manipulated people's preferences to increase profits without regard for psychological consequences, a scandal erupts. Harm from decision opacity. This is when an organization cannot explain the logic of AI decisions, and clients and regulators perceive the outcomes as arbitrary and unfair. For example, a person is denied a loan. When asked why, the bank answers, "That's the algorithm's decision." The client feels they were treated arbitrarily and unfairly. They share their story online and it resonates with thousands of others. The bank's reputation as a reliable and fair partner begins to crumble. This is how harm is categorized under the NIST framework. It is important to remember, however, that almost any of the harms listed above caused by an algorithm also leads to legal liability, which typically comes in three forms. First, regulatory fines. Data protection laws such as the European GDPR impose massive penalties for misuse. If it turns out that a company's AI system collected or processed data unlawfully, or that its decisions led to discrimination, regulators may impose fines in the tens of millions of euros or even a percentage of the company's global annual turnover. Second, lawsuits. Any individual harmed by a biased or erroneous AI decision may sue and seek compensation. If there are thousands of such individuals and the AI operates at large scale, this results in large-scale class actions. Third, license revocation. In heavily regulated industries such as finance, healthcare, transportation and energy, systematic AI failures or violations of AI use requirements can lead to the worst-case scenario for a company. The regulator may simply revoke its license, fully prohibiting it from operating. In this lesson, we conducted a detailed analysis of the types of harm that AI can cause to organizations. We identified three primary categories of organizational harm: operational harm, harm to security and financial interests, and reputational harm. Ultimately, all these types of harm lead to serious legal consequences. Thus, organizational harm spans a wide spectrum of risks, from production line stoppages to loss of trust and legal sanctions. In the next lesson, we will move on to ecosystem-level consequences, when AI systems operate at a global scale. Thank you for your attention, and see you soon.